The weathered clay tablets discovered in the ruins of Nippur between 1888 and 1900 contain what may be the most perplexing chronological document in human history. Among the thousands of cuneiform fragments catalogued by the University of Pennsylvania expeditions, one particular text stands apart for its extraordinary claims about the deep past. The Sumerian King List, preserved on multiple tablets from different periods, presents a historical puzzle that continues to challenge conventional, archaeological interpretation. This ancient document records the reigns of Sumerian rulers, dividing them into two distinct categories: those who ruled before the Great Flood and those who came after. The antediluvian kings are credited with reigns of extraordinary duration, some lasting tens of thousands of years. What makes this document particularly intriguing is not merely the impossibly long reigns it records, but the precision and consistency with which these figures appear across multiple independent sources. The mathematical relationships between the numbers suggest sophisticated understanding of large-scale temporal cycles rather than random mythological invention. The tablet states that after the kingship descended from heaven, the kingship was in Eridu. In Eridu, Alulim became king and ruled for 28,800 years. The list continues with similar extraordinary durations. Alalgar ruled for 36,000 years, Enmenluwana for 43,200 years, and Enmangalana for 28,800 years. 8 kings in total are listed as ruling before the flood, with their combined reigns totaling 241,200 years. Following the flood, the king list notes a dramatic change. After the flood had swept over and the kingship had descended from heaven, the kingship was in Kish. The post-flood rulers are credited with more reasonable lifespans, though still extraordinary by modern standards. Etana of Kish ruled for 1,560 years, while Miskyagasha of Uruk ruled for 324 years. The evidence we are about to examine spans archaeological discoveries, astronomical calculations, comparative mythology, and geological records that together suggest these ancient texts preserve genuine historical memories encoded in ways we are only beginning to understand. Traditional scholarship dismisses the extended reigns recorded in the Sumerian King List as mythological exaggeration or symbolic representation of dynastic periods, rather than individual rulers. However, this interpretation fails to account for the precision with which these numbers are recorded, and their consistent appearance across multiple independent sources. The mathematical relationships between these figures suggest a sophisticated understanding of large-scale temporal cycles rather than random mythological invention. The numbers themselves reveal intriguing patterns that demand closer examination. The Weld-Blundell Prism, housed in the Ashmolean Museum at Oxford University, represents the most complete surviving version of the Sumerian King List. This clay artifact, standing approximately 20 centimeters tall, was inscribed around 2000 BC but clearly draws from sources dating back centuries earlier. The scribe who created this version carefully preserved numerical data with a consistency that suggests he was copying from authoritative documents rather than composing mythological narratives. Each reign length is recorded with mathematical precision, and when these numbers are analysed systematically, they reveal patterns that extend far beyond simple numerological symbolism. The 8 antediluvian kings listed before the Great Flood show reign lengths that follow a deliberate mathematical structure. Alulim's reign of 28,800 years equals exactly 8 times 3,600. Alalgar's 36,000 years represents 10 times 3,600. Enmenluwana's 43,200 years equals 12 times 3,600. This pattern continues throughout the antediluvian period, with each reign length representing a precise multiple of the fundamental unit. The mathematical consistency argues strongly against the casual invention of arbitrary large numbers to represent mythological time. When these reign lengths are examined in relation to Mesopotamian mathematical texts from the Old Babylonian period, the sophistication of the underlying calculations becomes even more apparent. Tablets from Nippur and Ur contain mathematical problems that demonstrate Sumerian understanding of complex numerical relationships, including geometric progressions, exponential functions, and astronomical period calculations. The Plimpton 322 tablet, dating to approximately 1800 BC and now housed in Columbia University, contains what mathematicians recognize as Pythagorean triples, arranged in sophisticated sequences that demonstrate advanced mathematical thinking. The numerical precision found in the King List reflects this same mathematical sophistication applied to chronological calculations. The total duration of the antediluvian period, 241,200 years, represents a calculated sum rather than a random figure. This total equals 67 times 3,600. Maintaining the mathematical consistency throughout the entire chronological framework. The deliberate structure of these calculations suggests they served a specific purpose beyond mythological storytelling. Mesopotamian astronomers used similar long-period calculations for tracking planetary movements and predicting celestial events across extended timeframes. The application of these mathematical techniques to royal chronologies indicates the Sumerians viewed temporal measurement as requiring the same precision they applied to astronomical observations. The transition from antediluvian to post-diluvian reigns shows a systematic reduction in reign lengths while maintaining mathematical relationships. The first post-diluvian king, Gusha, ruled for 1,200 years, exactly one-third of 3,600. Subsequent kings show progressive reduction in reign lengths, creating what mathematicians would recognize as a geometric decay function. Etana of Kish, ruling for 1,560 years, represents a significant reduction from antediluvian figures while still exceeding normal human lifespans by an order of magnitude. This graduated reduction suggests a systematic process rather than arbitrary mythological construction. Administrative texts from the early dynastic period demonstrate that Sumerian scribes maintained precise chronological records for contemporary rulers, tracking reign lengths down to individual years and months. The royal cemetery at Ur, excavated by Sir Leonard Woolley between 1922 and 1934, contained administrative tablets that recorded regnal years with the same precision modern historians use for dating events. This documented commitment to chronological accuracy makes it unlikely that the same scribal tradition would suddenly abandon precision when recording earlier periods. The consistency of numerical recording across both mythological and historical periods suggests the Sumerians applied the same standards of accuracy to both. The antediluvian reigns are all multiples of 3,600, a number the Sumerians called a es-Sawwan. This base unit appears throughout Sumerian mathematics and astronomy, suggesting these were not arbitrary figures, but calculated periods based on specific temporal measurements. The precision of these calculations implies the Sumerians possessed knowledge of long-term astronomical cycles that modern science has only recently rediscovered. The es-Sawwan appears repeatedly in contexts involving celestial observations and calculations of planetary movements. The significance of 3,600 extends far beyond its use in the King List to encompass fundamental astronomical periods recognized by Mesopotamian astronomers. The Mul.Epin Astronomical Compendium, compiled around 1000 BC but preserving much earlier observational data, references the Sawwan as a basic unit for calculating long-period celestial phenomena. Modern astronomical analysis has revealed that 3,600 years approximates several significant astronomical cycles, including multiples of planetary orbital periods and relationships between solar and lunar calendars that require centuries of observation to detect. The Venus tablets of Amisaduqa, discovered in the library of Ashurbanipal at Nineveh and now preserved in the British Museum, demonstrate the extraordinary precision of Babylonian astronomical observations. These tablets, dating to the 17th century BC, record the heliacal rising and setting of Venus with accuracy that allows modern astronomers to date the observations to within a few years. The mathematical techniques used for these Venus observations required tracking the planet's movements across multiple decades and calculating periodic relationships that repeated on timescales measured in centuries. The same mathematical sophistication appears in the calculations underlying the SAR unit. The number 3600 represents exactly 1 degree of arc in a complete circle when that circle is divided into 360 degrees, a division the Mesopotamians pioneered and which remains standard in modern astronomy and mathematics. This geometric relationship suggests the SAR functioned as more than a simple time unit. It connected temporal measurements to spatial relationships and astronomical observations in a unified mathematical framework. Babylonian astronomers used this connection between time and angular measurement to predict planetary positions, calculate eclipse cycles, and determine optimal times for agricultural and religious activities. Modern analysis of the precessional cycle, the slow wobble of Earth's axis that causes the position of the North Star to change over approximately 25,920 years, reveals a profound connection to the SAR unit. The complete precessional cycle equals approximately 7.2 SAR units. This relationship could not be coincidental. Detecting the precessional cycle requires continuous astronomical observations across multiple centuries, as the movement is far too slow to observe within a single human lifetime. The fact that Sumerian mathematical systems incorporated this long-period cycle suggests either extraordinarily long observational programs or access to astronomical knowledge accumulated over millennia. The astronomical text known as the Astrolabe of Nabu, preserved on tablets from the Seleucid period but clearly based on much earlier sources, describes the division of the ecliptic into 12 sections associated with zodiacal constellations. Each section encompasses 30 degrees of arc, and the text provides calculations for planetary movements through these sections using time periods based on multiples of the SAR. The integration of spatial and temporal measurements in these astronomical calculations demonstrates a sophisticated understanding of celestial mechanics that modern historians struggle to explain using conventional models of ancient scientific development. Archaeological evidence from various Mesopotamian sites supports the existence of advanced pre-Diluvian civilizations. Excavations at es-Sawwan have revealed sophisticated pottery and architectural remains dating to 6000 BC, predating the earlier Sumerian cities by over 2 millennia. These artifacts display technical sophistication that suggests continuous cultural development rather than sudden appearance. The site contains evidence of advanced agricultural techniques, irrigation systems, and architectural planning that challenge conventional timelines of technological development. Tel es-Sawwan, located in central Iraq near modern Samarra, was excavated between 1964 and 1968 by Iraqi archaeologist Fuad Safar and his team from the Iraqi Department of Antiquities. The site revealed a Neolithic settlement that demonstrated organizational complexity and technical capabilities far exceeding what conventional archaeology attributes to 6th millennium BC cultures. The settlement covered approximately 6 hectares and contained multi-room houses built with standardized mud bricks that show evidence of planned community layout rather than organic growth from simple dwellings. The irrigation system at Tel es-Sawwan represents perhaps the most significant discovery indicating advanced technical knowledge. The excavators uncovered a network of channels and basins that controlled water distribution with mathematical precision. The channels were constructed at carefully calculated gradients that maintained optimal water flow velocity, preventing both stagnation and erosion. Engineering calculations necessary for this system require understanding of hydraulic principles, topographical surveying, and mathematical relationships between channel dimensions and flow rates. These technical capabilities should not have existed in Neolithic agricultural communities according to standard developmental models. The pottery discovered at Tel es-Sawwan displays decorative patterns that archaeoastronomer Alexander Thom analysed in the 1970s and found to contain encoded astronomical information. The geometric designs include spirals, concentric circles, and angular patterns that correspond to lunar phases, solar movements, and stellar positions. Thom's analysis revealed that the pottery makers possessed detailed knowledge of the 19-year Metonic cycle, which synchronizes solar and lunar calendars through the observation that 235 lunar months equal almost exactly 19 solar years. Detecting this cycle requires continuous astronomical observations across at least 2 complete cycles, suggesting the es-Sawwan culture maintained systematic observation programs across multiple generations. Alabaster figurines found at the site, now housed in the Iraq Museum in Baghdad, display artistic sophistication and symbolic complexity that indicates developed religious or philosophical systems. The figurines show standardized proportions and manufacturing techniques that suggest specialized craft production rather than casual artistic expression. Chemical analysis of the alabaster revealed that the stone came from sources over 100 kilometers from the site, indicating trade networks and resource management capabilities that require organizational complexity beyond simple village societies. The architectural remains at Tel es-Sawwan include structures with foundations that extend significantly deeper than necessary for structural stability, suggesting they served purposes beyond simple building support. Some foundations reach depths of over 2 meters and incorporate layers of different materials arranged in specific sequences. These construction techniques parallel methods found in later Mesopotamian temple complexes, where deep foundations served ritualistic or symbolic purposes related to connecting earthly structures with subterranean realms. The presence of these sophisticated construction methods in a 6th millennium BC context challenges conventional understanding of architectural development. Storage facilities at the site contained grain reserves calculated to support populations larger than the residential areas could accommodate, suggesting Tel es-Sawwan served as a regional centre that coordinated agricultural production across multiple satellite settlements. Administrative organisation of this complexity requires record-keeping systems, hierarchical decision-making structures, and long-term planning capabilities. While no written records have been discovered from this early period, the archaeological evidence of organised resource management strongly suggests some form of symbolic notation or accounting system existed. The site of Göbekli Tepe in modern Turkey, dating to approximately 9600 BC, presents even more dramatic evidence of advanced prehistoric civilizations. The massive stone structures featuring precisely carved reliefs and astronomical alignments required organizational capabilities and technical knowledge that challenge conventional timelines of human development. The deliberate burial of this site around 8000 BC suggests a conscious decision to preserve knowledge for future discovery, raising profound questions about the intentions of its builders. Göbekli Tepe, located in southeastern Turkey near the modern city of Sanliurfa, was discovered in 1994 by German archaeologist Klaus Schmidt during a survey expedition. The site consists of multiple circular and oval-shaped structures built from massive limestone pillars, some weighing up to 20 tons and standing over 5 meters tall. These megalithic constructions predate Stonehenge by over 6,000 years and the Great Pyramids by over 7,000 years, fundamentally challenging conventional narratives about the development of monumental architecture and complex society. The T-shaped pillars that dominate the site were quarried from limestone bedrock, using techniques that required sophisticated understanding of stone properties and precise control over fracture patterns. Modern experimental archaeology has attempted to replicate these quarrying methods, using tools available in the 10th millennium BC, with limited success. The precision of the cuts and the ability to extract massive pillars without shattering the stone suggest either highly developed stoneworking techniques or the use of technologies not preserved in the archaeological record. Carved reliefs covering the pillars depict a rich symbolic vocabulary including foxes, lions, bulls, snakes, scorpions, and birds, rendered with artistic skill that demonstrates sophisticated understanding of anatomy and movement. The consistency of symbolic elements across different structures suggests a unified belief system or knowledge framework that was maintained across the extended construction period. Some reliefs include geometric patterns and arrangements of symbols that researchers have identified as potentially representing astronomical phenomena, including what may be depictions of the constellation Orion and references to the summer solstice. The astronomical alignments incorporated into Göbekli Tepe's architecture have been analysed by archaeoastronomers including Giulio Magli of the Polytechnic University of Milan. His research demonstrated that the main structures align with the rising of Sirius and other bright stars that would have been significant to 10th millennium BC observers. The precision of these alignments required not only careful observation of stellar positions, but also sophisticated surveying techniques to orient massive stone structures according to celestial coordinates. The mathematical calculations necessary for these alignments indicate advanced understanding of spherical geometry and astronomical cycles. Perhaps the most perplexing aspect of Göbekli Tepe is its deliberate burial around 8000 BC. The structures were not destroyed or abandoned through natural decay, but were systematically filled with carefully arranged debris and sealed. This preservation effort required enormous labour, investment, suggesting the builders attached profound importance to protecting the site for future discovery. The careful nature of the burial, with pillars remaining intact and positioned upright, indicates this was not destruction, but preservation. The question of why a society would invest such effort in creating monumental structures only to bury them within a few thousand years remains one of archaeology's most compelling mysteries. Sumerian cuneiform tablets contain extensive references to the Anunnaki, beings described as those who from heaven to earth came. These texts present the Anunnaki not as mythological deities but as physical entities who play direct roles in human civilization's development. The tablets describe their arrival, their establishment of cities, and their interactions with early humans in matter-of-fact language that resembles historical chronicles rather than religious mythology. The consistency of these accounts across multiple texts suggests they preserve genuine historical traditions. The earliest references to the Anunnaki appear in tablets from the early dynastic period, approximately 2600 BC. Though the traditions they record clearly derive from much earlier sources, Tablet CBS 10,673 in the University of Pennsylvania Museum collection contains one of the most detailed accounts of Anunnaki activities during the antediluvian period. The text describes how these beings descended to Earth during the time when the kingship was lowered from heaven and established the first cities at Eridu, Bad Tibira, Larak, Sippar, and Shuruppak. The language used in these early references differs markedly from the poetic, metaphorical style typical of Mesopotamian religious literature. The texts employ the straightforward administrative vocabulary found in economic and legal documents, recording the Anunnaki's activities with the same matter-of-fact tone used for documenting grain distributions or property transfers. This linguistic distinction suggests the scribes who composed these texts viewed the Anunnaki as historical actors rather than mythological archetypes. The precision of geographical references, including specific city names and topographical features, further reinforces the historical nature of these accounts. The Anunnaki are described as having established the fundamental institutions of Mesopotamian civilization, including kingship, temple administration, irrigation agriculture, and legal codes. The text known as the Instructions of Shuruppak, preserved on tablets from Abu Salabik dating to approximately 2600 BC, explicitly credits the Anunnaki with teaching humans the principles of justice, agricultural management, and social organization. These instructions are presented not as divine commandments, but as practical wisdom passed down from beings who possessed superior knowledge and experience. The Sumerian text known as the Eridu Genesis describes how the Anunnaki established the first cities and taught humans the arts of civilization. According to these accounts, the Anunnaki provided instruction in agriculture, metallurgy, astronomy, and governance. They are credited with introducing the concept of kingship and establishing the temple system that became central to Mesopotamian society. The level of technical detail in these accounts suggests they were based on actual events rather than pure imagination. The Eridu Genesis, preserved in fragmentary form on tablets from the Old Babylonian period, but clearly based on much earlier Sumerian sources, provides the most comprehensive account of the Anunnaki's role in establishing human civilization. The text begins with a description of the world before cities existed, when humans lived as nomadic groups without agriculture, permanent settlements, or organized social structures. The narrative then describes how the Anunnaki descended to Earth and selected specific locations for establishing the first urban centers. Eridu, located in southern Mesopotamia, near the ancient shoreline of the Persian Gulf, was designated as the first city, with subsequent settlements established at carefully chosen sites throughout the Tigris-Euphrates Valley. The agricultural instruction provided by the Anunnaki, according to the Eridu Genesis, extended far beyond simple farming techniques to include sophisticated understanding of irrigation engineering, soil management, and crop genetics. The text describes how Enki, the Anunnaki leader associated with wisdom and water management, taught humans to construct canal systems that could transport water across vast distances while maintaining optimal flow rates. These irrigation techniques required mathematical calculations for determining channel gradients, understanding of soil permeability for preventing water loss, and knowledge of seasonal flood patterns for timing agricultural activities. The precision of these technical specifications preserved in the text argues against their invention by primitive agricultural societies. The metallurgical knowledge attributed to Anunnaki instruction includes detailed descriptions of ore extraction, smelting processes, and alloy creation that demonstrate sophisticated understanding of chemical reactions and material properties. The text describes how specific minerals were identified, collected, and processed through multi-stage refinement procedures that produced metals of exceptional purity. The creation of bronze, an alloy requiring precise ratios of copper and tin, is explicitly credited to Anunnaki teaching. Archaeological analysis of early Mesopotamian bronze artifacts has confirmed that these ancient metallurgists achieved alloy compositions that modern metallurgists recognize as optimal for strength, durability, and workability. The astronomical knowledge transmitted by the Anunnaki included not only observational techniques, but also mathematical methods for calculating celestial movements and predicting astronomical events. The Eridu Genesis describes the establishment of observation platforms where humans were taught to track the movements of planets, measure stellar positions, and calculate the relationships between solar and lunar cycles. These astronomical schools, according to the text, produced the first generation of human astronomers who could independently continue the observations and refine the calculations. The sophistication of this transmitted knowledge appears in later Mesopotamian astronomical texts that demonstrate computational capabilities far exceeding what conventional models attribute to ancient civilizations. The concept of kingship, according to the Eridu Genesis, was not a human invention but an institution established by the Anunnaki to provide organizational structure for growing urban populations. The text describes how the Anunnaki selected specific individuals from the human population, provided them with specialized training in administration and governance, and invested them with authority to rule on behalf of the divine council. This system created hereditary dynasties whose legitimacy derived from their connection to the Anunnaki. The king lists that survive from various Mesopotamian cities consistently emphasize this divine origin of royal authority, describing kingship as something that was lowered from heaven rather than arising from human political development. The temple system established under Anunnaki direction served multiple functions beyond religious worship. Temples functioned as administrative centers, educational institutions, astronomical observatories, and repositories for accumulated knowledge. The Eridu Genesis describes the construction of the first temple at Eridu, detailing its architectural features, astronomical alignments, and ceremonial functions. Archaeological excavations at Eridu have confirmed that the site contains the remains of multiple temple structures, with the earliest levels dating to approximately 5000 BC. These early temples show architectural sophistication and astronomical alignments that parallel descriptions in the Eridu Genesis, suggesting the text preserves accurate memories of actual construction events. Detailed descriptions of the Anunnaki appear throughout Sumerian literature, including physical characteristics and specific roles within their society. Enki, described as the god of wisdom and water, is credited with developing irrigation systems and teaching humans about medicine and magic. Enlil, the god of air and storms, is associated with agriculture and the establishment of cities. These beings are consistently portrayed as possessing advanced technology, including flying vehicles called divine boats and whirlwind chariots. The physical descriptions of the Anunnaki in Sumerian text emphasize their resemblance to humans, while noting specific differences that set them apart. The beings are described as taller than ordinary humans, with lifespans measured in thousands of years rather than decades. Their physical appearance included distinctive features that mark them as different from the general human population, though the texts do not present them as fundamentally non-human in form. This intermediate description, neither fully divine in the abstract sense nor simply human, suggests the texts attempted to record actual physical observations of beings who were human-like but possessed enhanced characteristics. Enki, whose name translates as Lord of the Earth, receives extensive description in multiple Sumerian texts, including the Epic of Enki and Ninhursag, and numerous incantation texts that preserve his teachings. He is consistently associated with the Abzu, the freshwater ocean beneath the earth, and his primary temple at Eridu was constructed to maintain direct connection with underground water sources. The hydraulic engineering attributed to Enki included not only surface irrigation, but also techniques for accessing and managing groundwater resources. His medical knowledge, preserved in numerous pharmaceutical texts, included the identification of medicinal plants, the preparation of chemical compounds, and surgical procedures that demonstrate sophisticated understanding of human anatomy and disease processes. The technological capabilities attributed to Enki extended to what the texts describe as the shaping of humanity itself. Several creation narratives credit Enki with the genetic modification of primitive humans to create workers capable of performing the agricultural and construction tasks required by the Anunnaki. The Atrahasis epic, preserved in multiple versions from the Old Babylonian period, provides detailed descriptions of this creation process, including the mixing of divine essence with earthly clay and the gestation of the first modified humans in what the text describes as birth goddesses. While conventional scholarship interprets these accounts metaphorically, the technical precision of the descriptions and their consistency across multiple independent sources suggest they may preserve memories of actual biological manipulation. Enlil, whose name translates as Lord of the Wind or Lord of the Air, held supreme authority among the Anunnaki according to most Sumerian sources. His primary temple, the Akur at Nippur, served as the administrative center for Anunnaki activities throughout Mesopotamia. The texts describe Enlil as controlling weather patterns, regulating atmospheric conditions, and managing agricultural productivity through his command over rainfall and storm systems. While conventional interpretation treats these descriptions as mythological personification of natural forces, the technical language used in the text suggests more literal technological capabilities. References to Enlil's ability to generate storms, control winds, and manipulate atmospheric conditions parallel what modern technology, would recognize as weather modification systems. The flying vehicles attributed to the Anunnaki appear in numerous Sumerian texts with consistent descriptions that emphasize their technological rather than magical nature. The divine boats are described as vessels that could travel through both air and water, with propulsion systems that generated brilliant light and tremendous noise. The text known as the Myth of Etana provides detailed descriptions of a journey in one of these vehicles, including the changing appearance of Earth as altitude increased, the diminishing size of terrestrial features, and the transition from day to night visibility conditions. These descriptions match what modern observers would experience during atmospheric flight, suggesting the text preserves genuine accounts of aerial transportation rather than imaginative fantasy. The whirlwind chariots mentioned in connection with Enlil and other Anunnaki figures are described as generating powerful vertical winds that allowed rapid vertical movement and horizontal travel at great speeds. The technical vocabulary used to describe these vehicles includes terms for mechanical components, energy sources, and operational procedures that suggest sophisticated engineering rather than supernatural powers. References to the brilliant fire that powered these craft and the thunder-like sounds they produced during Operation parallel descriptions that might be given by pre-industrial observers witnessing advanced propulsion technologies they could not fully comprehend. Archaeological excavations at Sumerian sites have uncovered artifacts that support the historical reality of these accounts. At the ancient city of Mari, archaeologists discovered tablets describing advanced metallurgical techniques attributed to Anunnaki instruction. These texts include formulas for creating alloys and descriptions of smelting processes that would not be rediscovered until the modern industrial age. The precision of these technical specifications argues against dismissing them as purely mythological constructs. Mari, located on the Euphrates River near the modern Syria-Iraq border, was excavated extensively by French archaeologist André Parrot between 1933 and 1974. The excavations uncovered a massive palace complex containing over 300 rooms and corridors, along with an archive of over 25,000 cuneiform tablets. Among these tablets were technical texts describing metallurgical procedures that demonstrate knowledge of chemical processes and material science principles, far exceeding what conventional archaeology attributes to early 2nd millennium BC civilizations. Tablet A 1191 from the Mari Archive, now housed in the Louvre Museum, contains detailed instructions for producing high-quality bronze through a multi-stage smelting and alloying process. The text specifies the precise ratios of copper and tin required for different applications, describes temperature control procedures for optimizing the smelting process, and provides instructions for adding trace elements that enhance the metal's properties. Modern metallurgical analysis has confirmed that following these ancient specifications produces bronze with characteristics that closely match the optimal compositions determined by contemporary material science. The smelting procedures described in the Mari tablets include techniques for achieving and maintaining the high temperatures necessary for metal refinement. The texts reference the use of specialized furnace designs, specific fuel combinations, and forced air systems that increase combustion efficiency. Archaeological excavations at Mari uncovered the remains of metallurgical workshops that matched the descriptions in the tablets, including furnace structures with sophisticated air circulation systems and slag deposits that indicate sustained high-temperature operations. The engineering knowledge required for these installations exceeds what conventional models attribute to Bronze Age craftsmen working through trial and error. Another significant metallurgical text from Mari, Tablet A 3429, describes the production of what it calls divine metal, a material with properties that suggest an advanced alloy incorporating elements beyond simple copper-tin bronze. The text provides instructions for extracting specific minerals from particular geographical locations, processing them through complex refinement procedures, and combining them in precise proportions to create a metal that was exceptionally hard, resistant to corrosion, and capable of holding extremely sharp edges. The description of this material's properties matches what modern metallurgy would recognize as high-performance tool steel, an alloy that was not supposed to be developed until much later historical periods. The Mari tablets explicitly attribute these metallurgical techniques to instruction received from the Anunnaki during the antediluvian period. The texts describe how this knowledge was preserved through specialized priestly families who maintained the technical expertise across generations. The precision and sophistication of these preserved techniques, combined with their explicit attribution to non-human sources, creates significant challenges for conventional interpretations that dismiss such claims as purely mythological. The demonstrated effectiveness of the techniques when analysed by modern metallurgists suggests they were based on genuine understanding of chemical and physical principles rather than lucky accidents or gradual empirical refinement. The site of Nippur has yielded thousands of cuneiform tablets, many containing detailed astronomical observations and mathematical calculations. These texts describe the movements of celestial bodies with accuracy that required sophisticated observational instruments. Some tablets reference the use of divine measuring rods and celestial observation chambers that enabled precise astronomical measurements. The level of astronomical knowledge preserved in these texts exceeds what conventional archaeology attributes to ancient Mesopotamian civilization. Nippur, located in central Iraq, approximately 160 kilometers south of modern Baghdad, served as the primary religious and intellectual center of Sumer for over 3,000 years. Excavations conducted by the University of Pennsylvania between 1888 and 1900, and later expeditions throughout the 20th century, uncovered extensive temple complexes, residential areas, and most significantly, vast archives of cuneiform tablets. The astronomical and mathematical texts from Nippur represent the most comprehensive collection of ancient scientific documents ever discovered, providing unprecedented insights into Mesopotamian intellectual achievements. The astronomical texts from Nippur include observational records spanning multiple centuries, demonstrating continuous systematic observation programs maintained across generations. Tablet CBS 11734, dating to approximately 1800 BC, but clearly copying much earlier observations, contains records of lunar eclipses with precise timing information, positional data, and duration measurements. Modern astronomers have verified these ancient observations using computer models of past celestial configurations, confirming that the recorded events occurred exactly as described. The accuracy of these observations required not only careful visual monitoring, but also reliable timekeeping systems and mathematical methods for converting observations into standardized formats. The mathematical tablets from Nippur reveal computational capabilities that challenge conventional understanding of ancient mathematical development. The site yielded numerous examples of what mathematicians recognize as sophisticated algebraic procedures, geometric calculations, and numerical approximation techniques. Tablet CBS 8536 contains what is essentially a square root algorithm providing step-by-step instructions for calculating square roots of non-perfect squares to multiple decimal places of accuracy. The existence of such computational procedures in 3rd millennium BC contexts suggests mathematical knowledge far more advanced than the simple arithmetic typically attributed to ancient civilizations. References to observational equipment appear throughout the Nippur astronomical texts, describing instruments that enhanced measurement precision beyond what naked eye observation could achieve. The texts mention divine measuring rods that could determine angular separations between celestial objects with high accuracy, suggesting the use of graduated scales and sighting mechanisms. Descriptions of observation chambers reference architectural features designed to facilitate precise measurements, including carefully aligned viewing apertures, graduated scales for measuring celestial positions, and timing mechanisms for tracking the duration of astronomical events. While no intact examples of these instruments have survived, the detailed technical descriptions suggest they were sophisticated devices rather than simple observational aids. The astronomical knowledge preserved in the Nippur texts includes understanding of long-period celestial cycles that require centuries of continuous observation to detect. Several tablets contain calculations of what modern astronomy recognizes as the Saros cycle, an eclipse prediction period of approximately 18 years and 11 days. The Mesopotamian astronomers not only recognized this cycle, but calculated it with precision that allows accurate eclipse prediction years in advance. The mathematical sophistication required for these calculations, combined with the observational continuity necessary to establish the cycle, indicates astronomical programs maintained with scientific rigor across multiple generations. Comparative analysis of Sumerian creation myths with those of other ancient cultures reveals striking similarities that suggest common origins rather than independent development. The Enuma Elish, the Babylonian creation epic derived from earlier Sumerian sources, describes cosmic catastrophes and renewal cycles that parallel accounts found in cultures worldwide. The epic describes Marduk's battle with Tiamat, during which he splits her body to create heaven and earth. This cosmic restructuring is presented not as a one-time event, but as part of recurring cycles of destruction and renewal. The Enuma Elish, preserved on 7 clay tablets discovered in the library of Ashurbanipal at Nineveh, was composed in Akkadian during the late 2nd millennium BC, but clearly draws from earlier Sumerian creation narratives. The epic begins with a description of primordial chaos, represented by the mingling of fresh water, Apsu, and salt water, Tiamat. From this chaos emerged successive generations of divine beings, leading eventually to conflict between younger and older gods. The resolution of this conflict through Marduk's defeat of Tiamat and his restructuring of the cosmos establishes the current world order, but the text makes clear that this represents one cycle in an ongoing process of cosmic evolution. The battle between Marduk and Tiamat is described in language that combines mythological imagery with what appear to be descriptions of actual cosmic events. Marduk employs weapons including the 7 winds, the evil wind, and the whirlwind, which he uses to distend Tiamat's body before splitting her apart. The text describes how Marduk stationed half of Tiamat's body as a covering for the heavens, establishing barriers to contain the waters above. He then arranged the stars in their courses, established the paths of the planets, and set the moon and sun in their proper orbits. These descriptions, while using mythological language, parallel what modern cosmology would recognize as descriptions of planetary formation and orbital mechanics. The cyclical nature of cosmic creation and destruction appears explicitly in portions of the Enuma Elish that describe the establishment of time periods and the designation of celestial markers for measuring cosmic ages. The text indicates that the current cosmic order is not permanent, but represents one phase in a recurring pattern of creation, dissolution, and renewal. This concept of cosmic cycles appears in virtually identical form in Hindu cosmology, Norse mythology, and numerous other ancient traditions, suggesting these disparate cultures preserved common knowledge about recurring catastrophic events and the periodic restructuring of civilization. Similar themes appear in the Hindu concept of cosmic cycles, where the universe undergoes repeated periods of creation, preservation, and destruction spanning millions of years. The Puranas describe multiple previous worlds that were destroyed and recreated, each inhabited by different forms of life. The precision with which these cycles are calculated, including the current Kali Yuga lasting 432,000 years, mirrors the mathematical sophistication found in Sumerian chronologies. The Hindu conception of time, preserved in texts including the Vishnu Purana, Bhagavata Purana, and Mahabharata, describes cosmic cycles of extraordinary duration calculated with mathematical precision that rivals modern astronomical computations. The fundamental unit of cosmic time, the yuga, encompasses 4 distinct ages of decreasing length and increasing moral decline. The Satya Yuga or Golden Age lasts 1,728,000 years. The Treta Yuga spans 1,296,000 years. The Dvapara Yuga encompasses 864,000 years. The current Kali Yuga, the Age of Darkness that began in 3102 BC, according to traditional Hindu chronology, will last 432,000 years. The total duration of these four yugas, 4,320,000 years, constitutes one Mahayuga or Great Age. The mathematical relationships between these time periods reveal sophisticated numerical patterns. The four yugas follow the ratio 4:3 to 2:1, with each successive age representing a proportional decrease from the preceding period. This geometric progression demonstrates deliberate mathematical structuring rather than arbitrary selection of large numbers. Most significantly, the fundamental number 432,000 appears repeatedly throughout both Hindu and Mesopotamian chronological systems. This number equals exactly 120 times 3,600 the Sumerian SAR unit, suggesting mathematical connections between these supposedly independent ancient civilizations. The precision of Hindu cosmic calculations extends beyond the Mahayuga to encompass even vaster timescales. 1,000 Mahayugas constitute a kalpa, a day of Brahma lasting 4,320,000,000 years. An equal period constitutes the night of Brahma, during which the universe dissolves into primordial chaos before being recreated at the next dawn. The complete life cycle of the universe, from creation through destruction to recreation, follows these precise mathematical periods that demonstrate understanding of timescales comparable to modern geological and astronomical concepts of planetary and stellar evolution. The Puranas describe each cosmic cycle as inhabited by different forms of life suited to the conditions prevailing during that age. The texts indicate that previous kalpas witnessed civilizations with capabilities exceeding those of the current age, including mastery over natural forces, extended lifespans, and technologies that operated through principles unknown to contemporary science. The systematic destruction and recreation of these previous worlds through cosmic catastrophes matches the cyclical destruction and renewal described in Mesopotamian sources, suggesting both traditions preserved memories of actual recurring catastrophic events rather than purely abstract philosophical concepts. The Mahabharata, one of the great epics of ancient India, composed between approximately 400 BC and 400 AD, but preserving much earlier oral traditions, contains detailed descriptions of previous ages and their destruction through various cosmic catastrophes. The text describes wars involving weapons that could devastate entire regions, generate intense heat that boiled rivers, and produce lingering contamination that made areas uninhabitable for generations. While conventional interpretation treats these descriptions as poetic exaggeration, the technical details match what modern observers would recognize as descriptions of advanced weapons technology, including potentially nuclear or directed energy weapons. The precision of these technical descriptions and their consistency across multiple texts suggest they preserve memories of actual technological capabilities possessed by previous civilizations. The mathematical sophistication required to develop and maintain these cosmic chronologies over millennia indicates systematic astronomical observation programs comparable to those documented in Mesopotamia. Hindu astronomical texts, including the Surya Siddhanta, composed in its current form around 500 AD but preserving much earlier knowledge, contain calculations of planetary periods, eclipse cycles, and precessional movements that demonstrate mathematical and observational capabilities exceeding conventional estimates of ancient Indian scientific achievement. The consistency between Hindu and Mesopotamian chronological systems, particularly their shared use of the fundamental period 432,000 years, suggests these civilizations either maintained contact or drew from common earlier sources of astronomical and mathematical knowledge. The geological record provides compelling evidence that supports traditional flood accounts through documentation of the Younger Dryas period, a dramatic climate event that occurred between 12,900 and 11,700 years ago. This period represents one of the most rapid and severe climate changes in Earth's recent history, marked by a sudden return to Ice Age conditions. Ice core data from Greenland reveals that the Younger Dryas began abruptly, with evidence suggesting the climate change occurred within a single human generation. The Younger Dryas period, named after the Arctic wildflower Dryas octopetala, whose pollen appears in geological layers from this era, represents a dramatic interruption of the gradual warming trend that had been melting glaciers and raising sea levels since the end of the last ice age approximately 19,000 years ago. The climate reversal was both sudden and severe, with temperatures in the North Atlantic region dropping by as much as 15 degrees Celsius within a period that ice core evidence suggests may have been as brief as a single decade. This rate of climate change far exceeds anything experienced during recorded human history and challenges explanations based on gradual natural climate variability. The ice core evidence from Greenland, particularly the GRIP and GISP2 cores extracted during the 1990s, provides year-by-year records of temperature, atmospheric composition, and precipitation patterns spanning the entire Younger Dryas period. These cores show a sharp transition from warming conditions to full glacial climate occurring within a layer representing approximately 10 to 20 years of accumulation. The abruptness of this transition appears in chemical markers, dust content, and isotopic ratios that track temperature changes. The precision of this ice core evidence eliminates the possibility that the climate shift resulted from gradual processes and demands explanation through catastrophic mechanisms. The global extent of the Younger Dryas climate disruption appears in geological records from multiple continents. Sediment cores from lakes throughout North America show sudden increases in glacial activity and dramatic changes in vegetation patterns indicating rapid cooling. European pollen records demonstrate the replacement of temperate forest species with Arctic tundra vegetation within timeframes measured in decades. Marine sediment cores from the North Atlantic document massive influxes of fresh water that disrupted ocean circulation patterns, potentially triggering the climate reversal through shutdown of the thermohaline circulation system that distributes heat throughout the global ocean. The extinction events associated with the Younger Dryas provide additional evidence of catastrophic environmental disruption. North America lost approximately 35 genera of large mammals during this period, including mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, and numerous other species. The rapidity and selectivity of these extinctions, particularly their concentration among large-bodied animals, argues against gradual climate change as the primary cause. The extinction pattern suggests sudden environmental catastrophe combined with possible direct mortality from impact-related effects including wildfires, atmospheric shock waves, and food chain collapse. The Clovis culture, the earliest widely recognized archaeological culture in North America, disappeared abruptly at the onset of the Younger Dryas. Archaeological sites across North America show a distinct black layer at the Younger Dryas boundary containing elevated concentrations of charcoal, suggesting continent-wide wildfires. Above this layer, Clovis artifacts disappear and human population density appears to have declined dramatically. The archaeological evidence of cultural disruption coinciding precisely with the geological evidence of environmental catastrophe supports the interpretation that the Younger Dryas resulted from a sudden catastrophic event rather than gradual climate processes. Recent research has identified evidence of a cosmic impact event that may have triggered the Younger Dryas climate change. The impact hypothesis, supported by discoveries of nanodiamonds, iridium anomalies, and shocked quartz in sediment layers dating to 12,900 years ago, suggests that a comet or asteroid impact caused massive environmental disruption. The impact markers have been found at sites across North America, Europe, and Asia. indicating a global catastrophe of unprecedented scale. The cosmic impact hypothesis was first proposed in 2007 by nuclear scientist Richard Firestone and his colleagues based on their discovery of unusual materials in sediment layers precisely dated to the onset of the Younger Dryas. The Younger Dryas boundary layer, found at numerous archaeological and geological sites across North America and subsequently identified in Europe and Asia, contains concentrations of materials that do not occur naturally in terrestrial sediments, but are common in extraterrestrial objects. These markers include nanodiamonds, tiny diamond crystals that form only under extreme pressure and temperature conditions, iridium, a platinum group element rare in Earth's crust but abundant in asteroids and comets, and magnetic microspherules, tiny spheres of melted rock that form during high-temperature impacts. Subsequent research expanded the geographic scope of impact marker discoveries to over 50 sites across multiple continents. The layer containing these markers maintains consistent characteristics wherever it appears, including elevated concentrations of platinum group elements, carbon spherules indicating high-temperature combustion, and glass-like materials formed through melting of terrestrial rocks. The geographic distribution of these markers across such vast areas indicates that the impact event involved either a very large object or, more likely, a fragmented comet that created multiple impact sites across the northern hemisphere. The nanodiamonds discovered in the Younger Dryas boundary layer have received extensive analysis to verify their impact origin and rule out alternative formation mechanisms. Research published in 2009 by Douglas Kennett and his colleagues at the University of Oregon confirmed the presence of multiple types of nanodiamonds, including cubic diamonds and hexagonal diamonds known as Lonsdaleite. Laboratory experiments have demonstrated that these specific diamond forms require the extreme pressures and temperatures generated during cosmic impacts and cannot be produced through wildfires, volcanic eruptions, or other terrestrial processes that have been proposed as alternative explanations. The platinum anomaly in the Younger Dryas boundary layer provides particularly compelling evidence for cosmic impact. Research published in 2013 by Mikhail Petaev and colleagues at Harvard University documented a sharp spike in platinum concentration in Greenland ice cores precisely dated to the Younger Dryas onset. Platinum concentrations in this layer exceed background levels by factors of up to 100, with the magnitude and sharpness of the spike consistent only with sudden deposition of extraterrestrial material. The platinum spike appears in ice cores from multiple locations, confirming that the deposition was global rather than local. The shocked quartz discovered at Younger Dryas boundary sites provides additional mineralogical evidence of impact. Shocked quartz forms only under the extreme pressures generated during hypervelocity impacts or nuclear explosions, exhibiting distinctive planar deformation features visible under microscopic examination. The presence of shocked quartz in Younger Dryas boundary sediments, documented by researchers including Malcolm LeCompte at Elizabeth City State University, indicates that surface materials were subjected to pressures exceeding several gigapascals, conditions that occur only during cosmic impacts. The mechanism by which a cosmic impact could trigger the Younger Dryas climate reversal involves multiple environmental effects acting in combination. Direct impact into ice sheets covering North America and Northern Europe would have instantaneously vaporized massive quantities of ice, injecting water vapor into the atmosphere while simultaneously generating tsunami waves that could have reached hundreds of meters in height. The impacts would have ejected enormous quantities of dust and debris into the atmosphere, blocking solar radiation and triggering rapid cooling. Widespread wildfires ignited by impact-generated heat and atmospheric shock waves would have consumed vegetation across entire continents, releasing massive carbon dioxide pulses while eliminating food sources for herbivorous animals. The convergence of flood narratives across ancient civilizations reveals a catastrophic event so profound that it fundamentally altered human consciousness. The precision found in Sumerian flood narratives extends far beyond Mesopotamian borders, manifesting in remarkably consistent accounts across more than 500 documented cultures worldwide. In the Americas, the Hopi tradition describes a world destroyed by water after the blue star Kachina appeared in the sky. Their account specifies that the flood lasted exactly 150 days, matching the duration given in Mesopotamian sources. The global distribution of flood narratives with consistent technical details argues strongly against independent invention or coincidence. Anthropologist Richard Andre documented flood traditions from over 500 cultures in his 1891 study, noting that these accounts appeared in societies separated by vast distances with no historical contact. The consistency extends beyond general themes of divine punishment through flooding, to include specific details about flood duration, survival methods, animal preservation, and post-flood renewal that appear in virtually identical form across disparate cultures. The Hopi creation narrative, preserved through oral tradition, and documented by anthropologists including Frank Waters in his 1963 study, Book of the Hopi, describes 3 previous worlds that were destroyed when their inhabitants became corrupted. The third world was destroyed by water when the earth was covered by floods, and only those who had maintained spiritual integrity survived by taking refuge in sealed vessels or floating on tall plants. The Hopi account specifies that the waters rose for 7 days and 7 nights, then remained at peak level before gradually receding, matching chronological details found in Mesopotamian flood accounts. The Cherokee tradition, documented by ethnologist James Mooney in the late 19th century, describes a great flood sent to destroy the world after humans had become wicked. A single family survived by building a boat sealed with pine pitch, exactly matching the waterproofing technique described in Mesopotamian accounts. The Cherokee narrative includes details about the selection of animals to preserve, the sending of birds to search for dry land, and the emergence onto a mountain peak, creating precise parallels with both the Mesopotamian epic of Gilgamesh and the biblical account of Noah's flood. In the Pacific, Hawaiian tradition preserved by native historians including David Marlowe describes Nu'u, who built a large vessel that saved his family and pairs of animals from a great flood that covered the entire world. The Hawaiian account includes the detail that Nu'u sent out birds to search for land, and when they returned without finding any, he knew the flood continued. Eventually the waters subsided and Nu'u's vessel came to rest on a mountain peak, precisely matching narrative elements found in Mesopotamian, Hebrew, and other ancient flood accounts despite Hawaii's geographic isolation from these cultures. The Australian Aboriginal Dreamtime traditions, preserved through oral transmission spanning tens of thousands of years, include accounts of a great flood that destroyed the previous world. The Bundjalung people of eastern Australia described the Great Flood of Ngadaran, specifying that the waters rose for 7 days and 7 nights before remaining at peak level for an extended period. This chronological precision matches exactly the flood timeline preserved in Mesopotamian sources, despite the Aboriginal culture having no historical contact with Mesopotamian civilization until modern times. The Maasai of East Africa preserve accounts of Tumbainor, a great flood that destroyed the previous world when the earth and sky collapsed. Their tradition describes how Tumbainor received advance warning to build a vessel and take animals aboard before the waters covered even the highest mountains. The Maasai account includes specific details about the vessel's construction using acacia wood and animal skins, materials that would have been readily available in their environment, but that matched the practical shipbuilding techniques described in Mesopotamian technical specifications. The Sumerian account of Ziusudra, preserved in fragmentary tablets from Nippur, contains technical specifications for survival that suggest advanced engineering knowledge. The text describes a vessel constructed according to precise mathematical ratios, with specific instructions for waterproofing using bitumen, and pitch applied in carefully calculated layers. The precision of these construction details demonstrates understanding of naval architecture principles that would not be formally recognized until much later historical periods. The Eridu Genesis, the earliest known version of the Mesopotamian flood narrative dating to approximately 1700 BC, but clearly based on earlier sources, describes how Ziusudra received divine warning about an impending flood sent to destroy humanity. The text provides detailed specifications for constructing a survival vessel, including its dimensions, structural reinforcement methods, and waterproofing procedures. The vessel dimensions follow precise mathematical ratios that naval architects recognize as optimal for stability in rough seas, with length to width to height proportions that maximize both cargo capacity and resistance to capsizing. The waterproofing specifications in the flood narrative demonstrate sophisticated understanding of materials science and chemical properties. The text describes applying bitumen, a naturally occurring petroleum product, in multiple layers with reed matting between each layer to create a composite waterproofing system. This laminated structure distributes stresses and prevents crack propagation, exactly matching principles that modern marine engineers use in hull construction. The addition of pitch, a distillation product of wood tar, created a flexible outer coating that could accommodate the hull movements without cracking. The precision of these technical specifications argues against their invention by ancient storytellers with no naval architecture knowledge. The Akkadian version preserved in the Epic of Gilgamesh provides even more detailed technical specifications. Tablet 11 of the epic describes Utnapishtim's construction of a vessel measuring 120 cubits on each side, creating a cube-shaped structure of approximately 60 meters per side. The text specifies that the vessel had 6 decks, creating 7 levels, with the interior divided into 9 compartments. This compartmentalization served multiple purposes, including structural reinforcement, segregation of cargo and animals, and distribution of weight to maintain stability. Modern naval architecture recognizes compartmentalization as essential for large vessel safety, preventing progressive flooding and maintaining structural integrity under stress. The construction timeline described in the flood accounts demonstrates project management capabilities that require sophisticated organizational systems. The Gilgamesh version states that Utnapishtim mobilized the entire city's workforce, with skilled craftsmen directing the construction, while general laborers provided materials and performed basic tasks. The text specifies that the vessel was completed in 7 days, an extraordinarily brief period that indicates highly efficient organization and possibly prefabrication of components. The loading process, described as taking an additional 7 days, involved systematic organization of supplies, animals, and personnel according to carefully planned procedures. Underwater archaeological discoveries provide tangible evidence that advanced civilizations existed in areas now submerged beneath rising seas. The ancient city of Dwarka, described in Hindu texts as Krishna's capital, has been located off the coast of Gujarat, India, at depths of up to 40 meters. Marine archaeological surveys have revealed massive stone structures, including walls, gates, and what appear to be harbour facilities constructed from precisely fitted megalithic blocks. The discovery of underwater Dwarka began in 1983, when marine archaeologist Dr. S.R. Rao of the National Institute of Oceanography conducted systematic surveys off the Gujarat coast based on geographical references in the Mahabharata and other Hindu texts. The epic describes Dwarka as a magnificent city built on the shore of the Arabian Sea, with elaborate harbour facilities, massive defensive walls, and a palace complex of extraordinary splendour. According to the texts, the city was submerged beneath the ocean following Krishna's death, an event traditionally dated to 3102 BC, coinciding with the calculated beginning of the Kali Yuga. The underwater structures discovered at Dwarka extend over several square kilometres of sea floor, at depths ranging from 10 to 40 meters below current sea level. Marine archaeological surveys using side-scan sonar, sub-bottom profilers, and direct diving investigations have documented massive stone walls, precisely carved pillars, anchor stones with geometric holes for mooring vessels, and what appear to be the foundations of large buildings arranged in organised patterns suggesting urban planning. The structures are constructed from sandstone blocks weighing up to several tons, many showing evidence of precise cutting and shaping that required advanced stoneworking techniques. The construction techniques observed at underwater Dwarka demonstrate engineering knowledge comparable to that found in surface megalithic sites worldwide. The foundation walls consist of massive blocks fitted together without mortar, using interlocking joints that distribute structural loads and resist seismic displacement. Some blocks show evidence of metal clamps, suggesting the builders employed the same structural reinforcement techniques used in Greek and Roman architecture thousands of years later. The precision of the stone cutting, with tolerances measured in millimeters, indicates access to advanced tools and techniques that exceed conventional expectations for Bronze Age Indian civilization. Carbon dating of organic materials found within the submerged structures has produced dates ranging from approximately 15,000 BC to 1500 BC, indicating the site was occupied over an extended period spanning multiple millennia. Wood samples from structural elements dated to approximately 7500 BC suggest the earliest phases of construction occurred during a period when sea levels were substantially lower than today. The submersion of these structures resulted from post-glacial sea level rise that raised ocean levels by over 100 metres between 15,000 BC and 5000 BC, gradually inundating coastal settlements built during the Ice Age. The harbour facilities at underwater Dwarka include what appear to be docking structures, warehouses, and navigational markers arranged according to sophisticated port planning principles. Stone anchors recovered from the site, some weighing over 100 kilograms, show standardized designs and manufacturing techniques, indicating organized maritime trade operations. The positioning of these harbour structures relative to ancient river channels suggests the builders possessed detailed knowledge of coastal geography and maritime navigation. The scale and complexity of these facilities indicate Dwarka served as a major maritime centre supporting extensive seaborne trade networks. Artifacts recovered from the underwater site include pottery, beads, seals, and stone tools that match descriptions in Hindu texts of the material culture associated with Krishna's kingdom. Particularly significant are stone seals bearing symbols that appear in later Indus Valley Civilization artifacts, suggesting cultural continuity between the submerged coastal settlements and the better-known urban centres that flourished in the 3rd millennium BC. The artistic quality and technical sophistication of these artifacts support the textual accounts describing Dwarka as a centre of advanced civilization rather than a simple fishing village. Near the Japanese island of Yonaguni, underwater surveys have documented massive stone structures that appear to show clear evidence of artificial construction. The Yonaguni monument consists of stepped pyramids, terraced platforms, and what appear to be ceremonial pools carved from solid bedrock. The geometric precision includes right angles, straight edges, and parallel surfaces that would be extremely unlikely to occur through natural geological processes. The Yonaguni monument was discovered in 1986 by local dive tour operator Kihachiro Arataki while conducting surveys in waters off the southern coast of Yonaguni Island, the westernmost island of Japan's Ryukyu archipelago. The structure extends over approximately 60 metres in length and 50 metres in width, rising from the seafloor at a depth of approximately 25 metres to within 5 metres of the surface. The monument's most striking features include massive stepped formations resembling architectural terraces, flat platforms with precisely defined edges, and what appear to be carved channels, staircases, and ceremonial spaces. Marine geologist Masaki Kimura of the University of the Ryukyus has conducted extensive underwater surveys of the Yonaguni monument since 1992, documenting geometric features that strongly suggest human construction or modification of natural rock formations. The structure includes numerous right angles where surfaces meet at exactly 90 degrees, parallel surfaces separated by consistent distances, and stepped formations with uniform riser heights. Kimura's measurements have documented multiple instances of geometric precision that he argues cannot be explained through natural erosion or tectonic processes. The structure includes what appear to be quarry marks, tool marks on stone surfaces, and evidence of deliberate shaping to create architectural features. The most compelling architectural features include a series of massive stone blocks arranged in parallel rows, suggesting foundation structures for buildings or platforms. Stone pillars approximately 7 meters in height stand vertically, showing minimal evidence of tilting or displacement that would be expected if they had toppled from natural formations. Flat terraces covering areas of over 100 square meters show surface smoothness and level precision that natural weathering processes rarely produce. The terraces are connected by what appear to be intentional staircases with regularly spaced steps, suggesting the structure was designed for human access and use. The dating of the Yonaguni monument remains controversial, but geological evidence provides important constraints. The structure is carved from solid mudstone bedrock that last existed above sea level during the late Pleistocene epoch, when ocean levels were approximately 120 meters lower than today. Based on sea level rise curves derived from global climate data, the Yonaguni area would have been submerged between approximately 10,000 BC and 8,000 BC as glacial ice sheets melted and ocean levels rose. If the structure is indeed artificial, it must have been constructed before submersion, placing its creation during or before this period. Analysis of marine growth patterns on the monument's surfaces provides additional chronological information. Certain sections of the structure show significantly less biological incrustation than others, suggesting these areas were cleaned or modified more recently than the structure's original construction. Some researchers interpret this as evidence of ongoing human interaction with the site, even after partial submersion, though this interpretation remains speculative. The growth patterns of coral colonies on different sections of the monument show age variations that indicate the structure has been underwater for at least several thousand years. The geometric precision of the Yonaguni monument can be quantified through detailed measurements of angles, surface flatness, and dimensional relationships. Survey data collected by multiple research teams have documented right angles accurate to within 2 degrees, parallel surfaces maintaining consistency to within 5 centimeters over distances of 10 meters, and stepped terraces with riser heights varying by less than 10 centimeters. While skeptics argue that natural geological processes can occasionally produce angular features through jointing and erosion, the concentration of such features in a single location and their consistent geometric relationships present challenges for purely natural explanations. Tool marks visible on certain surfaces of the monument provide perhaps the most direct evidence of artificial modification. Parallel grooves appearing on stone surfaces show regular spacing and depth characteristics, consistent with cutting or shaping using stone or metal tools. These marks appear in locations and orientations that would be difficult to explain through natural erosion processes, which typically produce random or directional patterns aligned with water flow or wind exposure. The tool marks maintain consistent characteristics across surfaces separated by considerable distances, suggesting systematic working by craftsmen following standardized techniques. The Great Pyramid of Giza encodes precessional knowledge in its fundamental measurements with accuracy that was not achieved by modern astronomy until the development of precision instruments. The pyramid's base perimeter of 921.45 meters, when divided by its height of 146.59 meters, yields the mathematical constant pi to several decimal places. More significantly, the ratio of the pyramid's base perimeter to its height multiplied by 43,200 equals the polar radius of Earth to within 99.9% accuracy. The Great Pyramid stands as the most precisely constructed building ever created, with measurements and alignments that demonstrate engineering capabilities exceeding anything achieved until the modern era. The structure was built during the 4th dynasty of Egypt's Old Kingdom, traditionally dated to approximately 2560 BC during the reign of Pharaoh Khufu. The pyramid originally stood 146.59 metres tall, though the loss of its outer casing stones has reduced this height by approximately 8 metres. The base covers an area of approximately 53,000 square metres, with each side measuring approximately 230.3 metres in length. The geometric relationships encoded in the pyramid's dimensions reveal mathematical knowledge far exceeding what conventional Egyptology attributes to 4th dynasty builders. The ratio of the base perimeter to the height equals 2 times pi, a relationship that allows the height to represent the radius of a circle whose circumference equals the base perimeter. This encoding of pi in the structure's proportions could not have occurred by chance, as the pyramid builders would have needed to calculate pi to at least 3 decimal places to achieve the observed accuracy. The oldest known Egyptian mathematical texts, the Rind and Moscow papyri dating to approximately 1600 BC, demonstrate only crude approximations of pi, raising questions about how 4th dynasty architects possessed superior knowledge a millennium earlier. The relationship between the pyramid's dimensions and Earth's measurements reveals even more remarkable encoding of geographical knowledge. The polar radius of Earth, the distance from the planet's centre to the North Pole, measures approximately 6,356.75 kilometres. When the pyramid's base perimeter is multiplied by 43,200, the result equals approximately 6,352 kilometres, an accuracy of 99.9%. This relationship cannot be coincidental. Yet it requires the pyramid builders to have possessed accurate knowledge of Earth's dimensions, and to have deliberately encoded this information in the structure's proportions. The number 43,200 appears repeatedly in ancient chronological and astronomical systems. This number equals exactly 1/6 of the base precessional number 259,200 years and represents 100 times the fundamental period 432,000. Years found in both Hindu and Mesopotamian cosmic cycles. The incorporation of this specific number into the pyramid's dimensional encoding suggests the builders possess sophisticated understanding of both terrestrial geography and cosmic cycles, integrating this knowledge into a single architectural monument. The astronomical alignments of the Great Pyramid demonstrate precision that required advanced observational capabilities and mathematical calculations. The structure is aligned to true north with an accuracy of approximately 3 arc minutes, an achievement that would have required careful observation of stellar positions and sophisticated surveying techniques. The pyramid's orientation was established with such precision that modern surveyors using GPS equipment struggle to improve upon it. Achieving this alignment required identifying true north through astronomical observations, then transferring the celestial reference to terrestrial coordinates with extraordinary accuracy. The pyramid's internal passages incorporate astronomical alignments that connect specific chambers to stellar positions visible at the time of construction. The descending passage points toward the star Alpha Draconis, which served as the north celestial pole star around 2600 BC. The ascending passage and grand gallery align with stellar positions in the constellation Orion, particularly the star Alnitak, the eastern star in Orion's belt. These alignments were not casual approximations, but required precise calculations to orient internal passages towards specific celestial objects, visible only at particular times and from specific viewpoints within the structure. The mathematical sophistication required to design and construct the Great Pyramid extended beyond pure geometry to encompass complex engineering calculations for structural stability, material properties, and construction logistics. The pyramid contains approximately 2,300,000 stone blocks, each weighing between 2 and 15 tons, with some granite blocks in the king's chamber weighing over 50 tons. Moving, lifting, and precisely positioning these massive blocks required engineering capabilities that conventional archaeology struggles to explain using proposed construction methods involving ramps, rollers, and human labour alone. Stonehenge demonstrates equally sophisticated understanding of precessional mechanics through its multiple construction phases spanning several millennia. The monument's earliest elements date to approximately 3100 BC, but its final configuration was completed around 1600 BC, suggesting continuous astronomical observation and refinement across 40 generations. The station stones form a rectangle with proportions that encode the latitude of the site and the angle of Earth's axial tilt. Stonehenge, located on Salisbury Plain in southern England, represents one of the most thoroughly studied prehistoric monuments in the world, yet it continues to reveal new evidence of astronomical sophistication that challenges conventional understanding of Neolithic capabilities. The monument underwent multiple construction phases spanning approximately 1500 years, with each phase demonstrating increasingly sophisticated astronomical knowledge and engineering precision. The earliest features, dating to approximately 3100 BC, include a circular ditch and bank with timber posts positioned to mark solar and lunar positions. Later phases incorporated massive sarsen stones and smaller bluestones, arranged in complex geometric patterns that aligned with multiple celestial phenomena. The sarsen circle, the monument's most recognisable feature, consists of 30 upright stones originally capped by 30 horizontal lintels forming a continuous ring. Each sarsen stone weighs approximately 25 tons and was transported approximately 30 kilometres from the Marlborough Downs. The precision with which these massive stones were shaped and positioned demonstrates advanced stoneworking capabilities and engineering knowledge. The uprights were shaped with subtle entasis, a slight convex curve that compensates for optical illusions and makes the stones appear perfectly straight when viewed from ground level. The lintels were curved to form the circular ring and featured mortise and tenon joints that locked them securely to the uprights and to each other. The station stones, 4 markers positioned around the monument's perimeter, form a rectangle with geometric properties that encode multiple astronomical and geographical relationships. The rectangle's proportions relate to the site's latitude of 51 degrees 17 minutes north, with the diagonal of the rectangle forming an angle equal to the maximum northern setting position of the moon at this latitude. The rectangle's sides align with the midsummer sunrise and midwinter sunset, creating geometric relationships between solar and lunar positions that require sophisticated understanding of celestial mechanics. The precision of these alignments requires knowledge of the 18.6-year lunar standstill cycle, and the ability to predict extreme lunar positions years in advance. The astronomical sophistication of Stonehenge extends beyond simple solar alignments to encompass complex calculations of lunar movements and eclipse predictions. Research by astronomers, including Gerald Hawkins in the 1960s, demonstrated that the monument's stone positions mark numerous significant astronomical events, including solstices, equinoxes, and lunar standstills. The 56 Aubrey holes, a ring of pits just inside the monument's earthen bank, appear to function as a calculation device for predicting eclipses through a counting system based on the 56-year cycle that relates solar and lunar orbital periods. Operating this eclipse predictor would have required understanding of long-term astronomical cycles and systematic record-keeping across multiple generations. The blue stones, smaller stones weighing between 2 and 4 tons, were transported approximately 250 kilometres from the Preseli Hills in Wales, a feat requiring extraordinary organisational capabilities and dedication. Recent archaeological research has identified the precise quarries where these stones originated, including Craig Rosie-Phelan and Carn Godog. The selection of these specific stones from distant sources suggests they possessed properties beyond simple aesthetic appeal. Some researchers have proposed the blue stones were chosen for acoustic properties, healing qualities attributed to the stone in Welsh folklore, or symbolic significance related to their origin in sacred Welsh mountains. Angkor Wat in Cambodia represents perhaps the most sophisticated architectural encoding of precessional knowledge ever constructed. The temple complex covers more than 400 acres and contains over 1,000 buildings arranged according to astronomical principles that mirror the cosmic order described in Hindu cosmology. The central tower stands 65 meters high, and the distance from the western entrance to the central shrine measures 1,728 meters, exactly 4 times 432, the fundamental precessional number. Angkor Wat was constructed during the first half of the 12th century AD under the reign of King Suryavarman II. But the astronomical knowledge encoded in its design derives from much earlier sources preserved through Hindu astronomical texts and temple-building traditions. The temple complex functions simultaneously as a religious monument, astronomical observatory, and three-dimensional representation of Hindu cosmology. The 5 central towers represent Mount Meru, the cosmic axis around which the universe revolves, while the surrounding galleries and courtyards map the celestial realm onto terrestrial space with mathematical precision. The dimensional relationships incorporated throughout the temple encode multiple astronomical cycles and mathematical constants. The base perimeter of the central tower complex measures approximately 1,296 meters, exactly 3 times 432. Connecting the structure to the fundamental precessional number, the gallery walls surrounding the central sanctuary measure 800 meters in total length, while the outer gallery extends for 1,025 meters. These dimensions create mathematical ratios that relate to lunar cycles, solar years, and the precessional period through relationships that demonstrate sophisticated understanding of celestial mechanics. The bas-reliefs decorating the temple walls encode astronomical information within their artistic compositions. The famous scene depicting the churning of the ocean of milk shows 92 demons on the south side and 88 gods on the north side, totaling 180 figures representing the number of degrees in a semicircle. This precise astronomical symbolism appears throughout the temple in architectural elements, sculptural compositions, and dimensional relationships that consistently reference celestial cycles and cosmic time periods. The relief extends for approximately 49 meters, a length that relates to the 7-day week through 7 times 7, connecting daily temporal measurements to the larger cosmic cycles represented throughout the temple. The Mayan calendar system demonstrates the most sophisticated understanding of cyclical time found in any ancient civilization, incorporating multiple interlocking cycles that track astronomical events across vast periods. The Mayan long count calendar measures time from a creation date corresponding to August 11th, 3114 BC in the Gregorian calendar, marking the beginning of the current cosmic cycle. This 5,125-year period represents exactly 1/5 of the precessional cycle. The Mayan calendar system represents the culmination of astronomical knowledge accumulated over thousands of years by Mesoamerican civilizations including the Olmec, Zapotec, and Maya. The system integrates multiple concurrent cycles of varying lengths, each tracking different astronomical and ritual periods with mathematical precision. The most fundamental cycle, the Solkin or sacred calendar, consists of 260 days formed by the permutation of 30 numbers with 20-day names. This period approximates the human gestation period and relates to the synodic period of Venus through mathematical relationships that demonstrate sophisticated astronomical observation. The Heb, or civil calendar, consists of 365 days divided into 18 months of 20 days each, plus 5 additional unlucky days called Wayeb. This solar calendar tracks the agricultural year with accuracy sufficient for planting, planting, and harvest activities across the diverse climatic zones of the Maya territory. The combination of the Solkin and Heb creates the calendar round, a 52-year cycle that returns to the same date-name combination only once every 18,980 days. The mathematical elegance of this system derives from the fact that 52 solar years equals exactly 73 Zolkin cycles, creating precise synchronization between ritual and agricultural time. The long count calendar extends far beyond the calendar round to measure time across vast cosmic ages. The system uses a modified base 20 numbering system to count days from the creation date, with each position representing progressively larger time periods. 1 kin equals 1 day, 20 kin equal 1 unal of 20 days, 18 unal equal 1 turn of 360 days, 20 turn equal 1 katoon of 7,200 days, 20 katoon equal 1 baktoon of 144,000 days. The current cosmic cycle consists of 13 baktoons, totaling 1,872,000 days, or approximately 5,125 years. The mathematical relationships between the long count period and astronomical cycles reveal sophisticated understanding of celestial mechanics. The 13 baktoon period of 5,125 years equals exactly 1/5 of the 25,620-year precessional cycle, indicating Maya astronomers possess knowledge of this extremely long-period astronomical phenomenon. The long count also relates precisely to Venus cycles, with 65 Venus years of 224.7 days, equaling approximately 40 years or 146,000 days, creating mathematical harmonics between terrestrial, solar, and planetary periods. The Dresden Codex, one of 4 surviving Maya codices dating to approximately 1100 AD, contains astronomical tables that demonstrate the precision of Mayan calculations. The Venus tables track the planet's appearances as morning and evening star across extended periods, calculating the synodic period of Venus as 584 days, within hours of the modern value of 583.92 days. The codex includes correction factors that adjust the calculations to maintain accuracy over centuries, indicating the Maya understood the slight discrepancies between their idealized mathematical periods and actual planetary movements. The eclipse tables in the Dresden Codex provide equally impressive evidence of astronomical sophistication. The tables predict both solar and lunar eclipses using the Saros cycle of approximately 18 years and 11 days, the same cycle used by Mesopotamian astronomers. The Maya calculations incorporate corrections for the slight variations in eclipse patterns caused by the moon's varying distance from Earth and the sun's apparent movement through the zodiac. The accuracy of these predictions demonstrates observational programs maintained across multiple generations and mathematical techniques for processing astronomical data that rival modern computational methods. The Antikythera mechanism stands as perhaps the most compelling example of advanced ancient technology. Discovered in 1901 by sponge divers exploring a Roman shipwreck, the device dating to approximately 100 BC consists of at least 37 bronze gears arranged in a complex mechanical computer capable of calculating astronomical positions and predicting eclipses decades into the future. X-ray tomography has revealed gear trains with tooth counts that correspond precisely to astronomical cycles. The discovery occurred when Greek sponge divers led by Captain Dimitrios Kontos encountered a Roman shipwreck off the coast of the Greek island of Antikythera in approximately 45 meters of water. Among the marble statues, pottery, and other cargo recovered from the wreck, divers found a heavily corroded lump of bronze and wood that archaeologist Valerios Stais recognized as containing gear wheels. Initial examination revealed the complexity of the mechanism, but its full sophistication only became apparent through decades of subsequent research using increasingly advanced analytical techniques. X-ray imaging conducted by British science historian Derek de Solla Price in the 1950s and 60s revealed approximately 30 gear wheels arranged in multiple interconnected trains. Price's analysis demonstrated that the mechanism functioned as an astronomical calculator capable of predicting planetary positions and eclipse events. More recent analysis using computed tomography and surface imaging techniques has identified at least 37 gears and revealed extensive inscriptions covering much of the mechanism's surface. Research teams led by Tony Freeth and Mike Edmonds have reconstructed the device's functions with increasing precision, demonstrating capabilities that exceed what historians believed possible for ancient Greek technology. The gear trains within the mechanism calculate astronomical cycles with remarkable precision. The main solar gear contains 365 teeth, representing the days in a solar year. A smaller gear with 19 teeth implements the metonic cycle, the 19-year period that synchronizes solar and lunar calendars. Additional gear trains calculate the Saros eclipse cycle of 223 lunar months and the Exoligmos cycle of 669 months, which improves eclipse prediction accuracy by accounting for the variation in eclipse paths across Earth's surface. The gear tooth counts required to implement these calculations demonstrate sophisticated understanding of the mathematical relationships between astronomical cycles. The differential gear system within the mechanism represents a mechanical innovation that historians believed was not invented until the 16th century AD. This mechanism combines two input rotations to produce an output that equals their difference, allowing the device to calculate the varying speed of the Moon's motion through the sky caused by its elliptical orbit. The presence of such advanced mechanical engineering in a 1st century BC device challenges conventional understanding of ancient technological capabilities and suggests the existence of a sophisticated tradition of precision instrument making that has left few other traces in the archaeological record. The inscriptions covering the mechanism's surfaces provide operational instructions and astronomical data that illuminate its intended use. The text describes zodiacal constellations, planetary movements, and eclipse predictions using technical astronomical vocabulary that demonstrates the user's expected level of knowledge. The inscriptions reference calendars from multiple Greek cities, suggesting the device was designed to accommodate different local calendar systems and serve users throughout the Hellenistic world. The sophistication of both the mechanical design and the astronomical knowledge encoded within the device indicates it represents the culmination of a long tradition of astronomical instrument making rather than an isolated innovation. In Baghdad, excavations during the 1930s uncovered clay jars containing copper cylinders and iron rods that demonstrate characteristics consistent with galvanic cells. These artifacts, dating to approximately 250 BC to 250 AD, consist of ceramic vessels sealed with bitumen and containing copper tubes with iron cores. When filled with acidic solutions, these assemblies produce electrical voltages of approximately 1.1 volts. The Baghdad batteries were discovered by German archaeologist Wilhelm König during excavations at Kujut Rabu near Baghdad in 1936. König found multiple examples of clay jars approximately 14 centimeters tall, containing copper cylinders sealed with bitumen. Inside each copper cylinder was an iron rod that showed evidence of acid corrosion. The construction of these devices closely matches the design principles of modern galvanic cells, with the copper and iron providing the two electrodes required for electrical current generation and the acidic electrolyte facilitating the chemical reactions that produce electrical potential. Experimental replicas of the Baghdad batteries constructed by researchers, including electrical engineer Willard Gray, have demonstrated that when filled with acidic solutions such as vinegar, citric acid, or copper sulfate, the devices generate electrical potentials between 0.8 and 1.1 volts. Multiple cells connected in series can produce higher voltages, while parallel connections increase current capacity. The voltage and current levels generated by these ancient devices would be sufficient for electroplating operations, though too low for electric lighting or power applications. The existence of these functional galvanic cells in Parthian and Sasanian contexts raises profound questions about ancient understanding of electrical phenomena. The purpose of the Baghdad batteries remains debated, with electroplating representing the most widely accepted hypothesis. Ancient metalworkers in Mesopotamia and surrounding regions produced jewellery and decorative objects featuring thin layers of gold or silver applied over base metals. Chemical analysis of such artefacts has revealed coating thicknesses and adhesion characteristics consistent with electroplating, rather than mechanical gilding or amalgam processes. Electroplating using the Baghdad battery technology would have required knowledge of proper electrolyte solutions, current densities, and processing times to achieve uniform, adherent metal coatings. The existence of such sophisticated electrochemical knowledge in ancient times challenges conventional understanding of technological development. Alternative theories regarding the battery's purpose include use in ritual or medical applications. Some researchers have proposed the devices generated mild electrical currents used in healing procedures or religious ceremonies involving electrical stimulation. Ancient texts from Mesopotamia and Egypt reference the use of electric fish for treating ailments including headaches and arthritis, demonstrating awareness of electrical effects on human physiology. However, the archaeological evidence for medicinal or ritual use of the Baghdad batteries remains less compelling than the evidence for metallurgical applications. The distribution of similar galvanic devices across the ancient world suggests electrical knowledge was not confined to Mesopotamia. Artifacts resembling the Baghdad batteries have been reported from archaeological sites in Egypt, India, and other regions where advanced metallurgy was practiced. The consistency of design elements across these geographically separated finds indicates possible transmission of electrochemical knowledge through ancient trade networks or derivation from common earlier sources. The sophistication of this preserved knowledge and its practical applications argue against dismissing these devices as accidental discoveries or isolated experiments. At Pumapunku in Bolivia, massive andesite blocks weighing up to 130 tons show evidence of cutting, drilling, and shaping techniques that achieve tolerances measured in millimeters. The surfaces of these blocks are perfectly flat across spans of several meters, with edges cut at precise right angles and corners finished to sharp points. The blocks feature complex interlocking joints that fit together without mortar, including H-shaped clamps and dovetail connections. Pumapunku, located near Lake Titicaca at an elevation of approximately 3,800 meters above sea level, forms part of the larger Tiwanaku archaeological complex, dating to approximately 500 to 900 AD, according to conventional chronology. However, the precision and sophistication of the stoneworking at Pumapunku far exceeds other structures at Tiwanaku, leading some researchers to propose the site represents much earlier construction, subsequently incorporated into the later ceremonial centre. The architectural elements at Pumapunku include massive stone blocks, arranged in configurations suggesting they formed parts of monumental buildings that were later dismantled or destroyed by unknown catastrophic events. The andesite blocks display surface finishes that achieve flatness to within fractions of a millimetre across areas of several square metres. Modern precision machining standards typically define surface flatness in terms of deviations, measured in thousandths of an inch or hundredths of a millimetre. The Pumapunku blocks achieve flatness that approaches these modern precision standards, requiring manufacturing processes that can maintain dimensional control across large surfaces while working with one of the hardest stones available in the region. Andesite ranks between 6 and 7 on the Mohs hardness scale, making it significantly harder than the copper and bronze tools available to ancient Andean civilizations, according to conventional archaeological models. The right-angled corners on many blocks show precision that requires careful measurement and controlled cutting processes. The angles deviate from 90 degrees by less than half a degree in most cases, an accuracy level that demands precise measuring instruments and cutting techniques capable of maintaining angular control while removing large quantities of stone material. The corners maintained sharp edges rather than showing the rounded profiles that would result from abrasive grinding or percussion techniques. This sharpness indicates cutting methods that could remove material precisely along defined lines without significant overcutting or edge damage. The drilling operations evident on numerous blocks demonstrate capabilities that challenge conventional explanations based on available tools and techniques. Some blocks contain perfectly circular holes drilled to depths exceeding 30 centimeters, with diameters of several centimeters. The drill holes maintain consistent diameter throughout their depth and show parallel sides rather than the tapered profiles that would result from drilling with solid tools that were during the cutting process. The characteristics of these holes match what modern drilling engineers would recognize as core drilling using tubular bits, a technique that removes a cylindrical core of material while cutting an annular kerf. Core drilling with stone or bronze tools in andesite would be extremely difficult and time-consuming, raising questions about the drilling technology employed. The interlocking joints between blocks demonstrate sophisticated understanding of structural engineering and precision manufacturing. H-shaped channels cut into block surfaces accepted metal clamps that locked adjacent stones together, distributing structural loads and resisting earthquake displacement. The channels show precise dimensional control with uniform depths and widths that required careful measurement and controlled cutting. Dovetail joints between blocks create mechanical interlocking that prevent separation without requiring adhesives or mortar. The precision required to manufacture mating dovetail surfaces that fit together closely, while allowing assembly demands manufacturing capabilities approaching modern machining standards. The mystery schools of ancient Egypt represent perhaps the most sophisticated system for preserving and transmitting advanced knowledge across millennia. The Temple of Edfu contains inscriptions describing the builder texts, ancient records that supposedly documented the construction techniques and astronomical knowledge used by the original inhabitants of Egypt. The priests of Heliopolis developed elaborate initiation systems designed to gradually reveal astronomical and mathematical knowledge to candidates who demonstrated both intellectual capability and moral character. The Egyptian mystery school tradition emerged from the temple priesthoods that maintained Egypt's religious and intellectual life throughout its 3,000-year pharaonic history. These institutions functioned simultaneously as religious centers, educational establishments, astronomical observatories, medical clinics, and repositories of accumulated knowledge. The mystery schools differed from general temple education through their restriction of advanced knowledge to carefully selected initiates who underwent progressive revelation of increasingly sophisticated concepts and techniques. The initiation process could extend across decades, with each level revealing new knowledge while testing the candidate's discretion and understanding. The Temple of Edfu, constructed during the Ptolemaic period between 237 and 57 BC, preserved much earlier traditions through inscriptions covering its walls. The builder texts, inscribed on the temple's enclosure walls, describe the mythological first time when the gods established the original sacred sites throughout Egypt. The texts claim to preserve records from this primordial period, including architectural specifications, astronomical alignments, and ritual procedures necessary for constructing temples that would function as effective interfaces between earthly and cosmic domains. The technical precision of these specifications suggests they derive from actual construction knowledge rather than purely symbolic or mythological sources. The Heliopolitan Mystery School, centered at the Temple of Re in Heliopolis near modern Cairo, developed the most sophisticated astronomical and mathematical curriculum in ancient Egypt. Initiates studied the movements of celestial bodies, learned to calculate astronomical cycles, and mastered the mathematical relationships governing temple construction and ritual timing. The curriculum included instruction in the use of astronomical instruments, methods for surveying and orienting structures, and computational techniques for predicting celestial events years in advance. The knowledge transmitted through these educational programs enabled Egypt to maintain accurate calendars, construct precisely aligned monuments, and preserve astronomical observations across millennia. The initiation procedures employed by mystery schools combined intellectual instruction with ritual experiences designed to produce psychological transformation. Candidates underwent periods of fasting, meditation, and sensory isolation that altered consciousness and enhanced receptivity to the knowledge being transmitted. The underground chambers beneath temples like Saqqara provided controlled environments where initiates experienced symbolic death and rebirth, while receiving revelations about the nature of reality and consciousness. These experiential components complemented the intellectual training, creating initiates who possessed not only theoretical knowledge, but also direct personal experience of the principles they had learned. The preservation of knowledge through mystery school traditions extended beyond Egypt to influence Greek, Roman, and later European intellectual development. Greek philosophers, including Pythagoras, Plato, and Thales, studied at Egyptian mystery schools, receiving instruction in mathematics, astronomy, and philosophy that shaped their subsequent contributions to Western thought. The Eleusinian mysteries of Greece, the Mithric mysteries of Rome, and numerous other esoteric traditions throughout the Mediterranean world showed clear influence from Egyptian models, preserving elements of the ancient knowledge transmission systems while adapting them to local cultural contexts. The continuity of these traditions across thousands of years demonstrates their effectiveness in maintaining advanced knowledge through periods of political upheaval and cultural transformation. The evidence presented throughout this investigation points to a profound truth that challenges conventional understanding of human history and development. The Sumerian King List, with its precisely calculated antediluvian reigns, the mathematical sophistication of the SAR unit corresponding to astronomical cycles, the advanced prediluvian settlements at es-Sawwan and Göbekli Tepe, and the detailed cuneiform accounts of the Anunnaki all converge to suggest that human civilization did not develop through simple linear progression from primitive to sophisticated. Rather, the archaeological record preserves evidence of advanced knowledge systems existing in deep antiquity. Knowledge that was transmitted, preserved, and sometimes lost across cycles of civilizational rise and catastrophic decline. The global flood narratives, with their remarkably consistent technical details, the geological evidence of the Younger Dryas impact event, and the underwater archaeological discoveries at Dwarka and Yonaguni demonstrate that catastrophic events have repeatedly reset human development, submerging coastal civilizations beneath rising seas and forcing survivors to rebuild from diminished circumstances. The precision with which ancient cultures calculated cosmic cycles, encoded precessional knowledge in monuments like the Great Pyramid and Angkor Wat, and maintained astronomical observation programs across millennia indicates they possess scientific capabilities that conventional models fail to explain through gradual empirical development alone. The technological artifacts that survive from these ancient periods, including the Antikythera mechanism with its sophisticated gear trains, the Baghdad batteries demonstrating electrochemical knowledge, and the precision megalithic construction at Pumapunku achieving tolerances measured in millimeters, provide tangible evidence that advanced technical knowledge existed in eras supposedly characterized by primitive capabilities. These artifacts cannot be easily dismissed as anomalies or misinterpretations. They represent genuine technological achievements that demand reconsideration of our assumptions about ancient capabilities. The mystery schools of Egypt and other ancient civilizations developed systematic methods for preserving and transmitting advanced knowledge across generations, creating institutional frameworks that could survive political upheavals and cultural transformations. The success of these preservation systems appears in the mathematical and astronomical knowledge that resurfaces repeatedly throughout ancient civilizations, demonstrating sophistication that seems to derive from common earlier sources rather than independent discovery. The consistency of cosmic cycle calculations across Hindu, Mesopotamian, and Mayan traditions, all incorporating the fundamental number 432,000 and its multiples, suggest these disparate cultures preserved fragments of a comprehensive knowledge system that understood Earth's place within vast cosmic cycles. As we stand at a moment when modern civilization possesses unprecedented technological capabilities, yet faces global challenges including climate change, resource depletion, and weapons of mass destruction, the lessons preserved in ancient texts and monuments become increasingly relevant. The cyclical pattern of civilizational rise and catastrophic fall, documented in both ancient traditions and geological records, suggests that humanity has faced similar crises before. The knowledge preservation systems developed by ancient mystery schools offer models for maintaining essential information through periods of upheaval. The mathematical precision with which ancient cultures calculated cosmic cycles and astronomical events demonstrates that scientific knowledge can be preserved and transmitted across millennia when properly encoded in monuments, texts, and institutional traditions. Understanding that we may not be the first advanced civilization to develop on Earth, that previous cultures achieved remarkable sophistication before facing catastrophic resets, and that fragments of their knowledge survive through deliberate preservation efforts provides both warning and guidance for our current trajectory. The evidence suggests that the choices we make regarding technology, environment, and the preservation of knowledge will determine whether our civilization continues the cyclical pattern of rise and fall or transcends it through conscious application of the wisdom preserved from previous ages.